Math 3 Lesson Summary Video. Circle Challenges. This lesson is a practice understanding task, which takes concepts you have been working on and applies them to new situations. The purpose of this lesson is to use different pieces of given information in order to write the equation of a circle. For this practice task, Malik and Sapana are challenging one another to write the equations of a circle given different pieces of information. You will want to go through and practice these problems yourself and try to see if you can figure them out. We're going to do a couple of examples together and hopefully remind you of the tools that you have in your toolbox to help you do these problems. Number 4, Sapana's challenge. The points 4, -1 and -6, 7 are the endpoints of the diameter of a circle. What is the equation of a circle? So things that I want to remember, if I'm going to write the equation of a circle, I want to remember what is the equation of a circle. So I know that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Don't forget hk is the center, because that's how it's been transformed. You know, we've shifted it. R is the radius. So these are the pieces of information I need in order to write the equation. Now, she did not give us the center, and she did not give us the radius, but she did give us 2 points that are on ends of the diameter. So if they're the ends of a diameter, we know a couple of things. We know that they are on the circle. We know if they are the ends of the diameter always goes through the radius. We know that the radius is half of the diameter. And we know that the center must be the midpoint of the diameter. So even though she didn't give us directly the radius and the center, I do think we have enough information to get what we need. We know that 1 point is -6, 7, and 1 point is 4, -1. So if I want to find the diameter of the circle, I actually have to find the distance between those 2 points. There are many ways that you can find the distance. Most people like the distance formula. If you're not a formula person, you just want to remember that anytime you're looking for the distance between 2 points, you can write those points as a right triangle. To find this distance, we just have to know what is the difference between the x's. So 4 minus -6 means that this side must be 10. And to find the distance of this side, we just have to find the difference of the y values. So 7 minus -1 is equal to 8. So the side of the triangle is 10, this side of the triangle is 8, and I can just do the Pythagorean theorem to figure out what that distance is. So it is just a squared plus b squared equals c squared. Some people like to use a big formula. They would just want to know straight up what is the distance. And the distance formula is based off of the Pythagorean theorem. So if I subtracted the x's to get that 10, I had to subtract the x's, and then that's my a. So I'm going to do a squared. And then to find my b, I had to subtract my y's. So I subtract my y's, and that's my b squared, and it's equal to c squared, or in this case, our distance squared. But if I just want the distance, I have to take the square root of both sides to get rid of the square. And so that's how we get the distance formula. So here is your actual formula, your distance formula, but if you ever forget it and you don't remember it, just remember it is the Pythagorean theorem. We're just doing a squared plus b squared equals c squared. So for this problem, that's going to be 10 squared plus 8 squared is equal to c squared, or 164 is equal to c squared. So when I take the square root of both sides, I'm going to get that distance, the diameter, is equal to the square root of 164. Now, as always, we want to reduce our square roots, reduce our radicals, and 64 seems like a very even number. So I'm pretty sure 164 will divide by 4, so I'm going to try at least to divide it by 4. And in fact, it is 4 times 41. So remember, if we can find two factors that one of them is a perfect square, we can reduce the square root. So the diameter is going to be 2 on the square root of 41. Now, that's the diameter. We need the radius. So I remember the radius is half of the diameter. So I need to take the diameter and take half of it. And if I do that, my 2's will divide out, and I'm just left that the radius is the square root of 41. So first thing I needed, I got it. I now know the radius of my circle. The next thing I need is to find my midpoint. And you may recall, again, if we're just kind of looking at right triangles and such, the midpoint is always halfway. So it's going to be halfway between the y values, and it's going to be halfway between the x values. And if you're doing halfway on a number line, so the x values is just the x number line and the y values is just the y number line, the middle number is always the average. So our midpoint formula, again, if you don't remember the formula, just remember it's always the middle, so it's always the average. If you take your two x values and just find their average, that's going to be the x value of your midpoint. If you take your two y values and just find the average, that's going to be the y value of your midpoint. So for this particular problem, we've got -6 and 4. So -6 plus 4 divided by 2. And for our y values, we have 7 and -1. So I'm going to end up with -2 divided by 2, which is -1. And 6 divided by 2, which is 3. So now I have the center of my circle because it's the midpoint between these 2 points. Now that we have the center and the radius, we can write the equation of the circle. So we want to do the x-coordinate, so x plus 1, because we always do the opposite, plus the y-coordinate, so we'll do y minus 3, because we always do the opposite. And the radius was square root of 41, but when you square a square root, the square and the square root cancel, and so this will just be equal to 41. Problem number 5, Malik's challenge. Is the point 5, 1 inside, outside, or on the circle x squared minus 6x plus y squared plus 8y equals 24? And how do you know? So things we want to remember about equations and points. If a point is on the line of an equation, on the graph of an equation, when you substitute x and y into that equation, you should get a true statement, meaning that both sides of the equal sign are equal to one another. So the easy way to figure out if it's on the circle is to just plug in the point. We're going to substitute 5 for x and 1 for y and see if we get 24. If we get 24, then we know that it is on the circle. So let's try it. If we have 5x squared minus 6 times 5 plus 1 squared plus 8 times 1 is equal to 24. So we're going to have 25 minus 30 plus 1 plus 8. So 25 minus 30 is -5 plus 1 plus 8. And we have -4 plus 8, which would be 4. So it looks like we did get a false statement. 4 is not equal to 24. So we know that this point is not on the circle. But how can we tell if it's inside the circle or outside the circle? One option is always to graph it. If you have a graphing utility like Desmos, you can type in the equation and type in the point, and you can see, does it fall inside the circle, outside the circle, or on the circle? But since I've already done all of this work, I feel like I want to use it to see whether or not this point was in the circle or not. And what we have to realize is that if we're using this point and we plugged it into this equation, we're basically finding the a squared plus b squared equals c squared. So we're looking at the hypotenuse of the circle that has this center but goes to this point. So we found that this circle that was at this center and went to this point had this for its hypotenuse squared, and our circle had 24 for its hypotenuse squared. That would imply that this one's hypotenuse was smaller. They had the same center, but this one was a smaller circle. That would imply that this point is inside the circle. In fact, anytime you substitute the points into the equation, if the number you get is less than whatever the radius squared or the number was over here, then we know that this was a point inside the circle. If the value that we get is greater than the number that was over here, then we know that our point was outside of the circle. And again, if we know that they're equal, then we know that it is on the circle.